Hello everyone, my name is Ahmed Zubaidi and I'm going to be your lecturer for the subject 4A621, Engineering Manufacturing. And through this subject we are going to learn many topics regarding the principle of the manufacturing. During this semester we have to do some practical work in the lab. We have to go through 3 assessments. The first one is going to be the engine block, we call it the minor project. The second one is going to be the major project, is going to be the gear pump, and also we're going to have the heaviest work is going to be for the manufacturing of the hand pump. Manufacturing of the hand pump will include the using of the equipment we have in this lab. We are going to supply you with the major material to make the basic pump, which is going to look something similar to this one. I'm going to deassemble this one for you soon to show you what's going to be the parts you have to make and what will be the way to make it. Some other students prefer to do more advanced pumps to pump high quantity of water, like the other 2 examples you can see here. This is a type of creativity. You can do it, and you can start with the basic design depending on your manufacturing capacity. If you have the time, if you have the resources, then you can build the advanced one. But if you just want to complete all the requirements of the passing for this it's not going to be assignment, you only have to make the principal pump. So I will keep everything away and I'm going to start to explain to you the hand pump. What is the hand pump? How it's work, and what we use it for, and what are the main parts of the hand pump. So from the name, the hand pump is we are going to use the hand power to pump the water. Now this one is actually not going to work nice because I think it was tested and it was not maintained, and that's what's caused that some of the corrosion happened inside. We're going to open this pump and we're going to see how it's work. So again, this pump is going to use the hand power to get the water from a lower level to a higher level. Usually this type of the pump, by testing, is going to pump something around 2.5 liters in the span of 2 minutes with the stroke of I think something about 5 strokes per minute. The pump working in very simple manner. Always in the pump we are either going to have a propeller, which is going to generate negative pressure from one side, higher pressure on the other side, and push the water, or we're going to have the piston type. So what we have here is a cylinder, as you can see. Inside the cylinder we have a piston and we have 2 valves, the lower valve and the piston valve, or what they call it, the piston valve. So by the movement of the piston is going to get the generate negative pressure when we pull it up. Okay, we're going to generate negative pressure. This negative pressure is going to open the base valve. It's going to be this opening here, and this will force the water to fill the cylinder. When we are going to push the piston down, this valve will be closed, the other valve will be open, and this will push the water from the lowest part of the cylinder to the upper part. By continuously repeating the process, the level of the water will start to increase until it's going to reach this level and start to pour to the tank. What this pump consists from, you saw the cylinder. Actually this is not going to be the main pump part. We're going to put it aside. Okay, so we have the T-junction. We're going to have the upper cylinder and the cup at the top. Okay, so 1, 2, 3, 4 parts so far. Okay. Now, this will be the piston, this will be the upper valve, and this is the main rod. I can simply deassemble that. Well, actually, as I told you, it's salty here, so that's why it resists a lot. Try to use I'll try to find something to open it with. I have something around, so I'm going to keep it just as one piece at the moment. And at the bottom, we're going to have the bottom valve. This washer is going to work as the bottom valve. And the main cylinder. So let's count the parts. I'm going to open that just to show you what will be the valve we have and how it's made. And this is the basic one because some students made more advanced valves at the bottom. Well, the design of the opening we're going to have here will decide how much water we're going to pull every time. So bigger is going to get more water flow, and this will increase the performance of the pump and the flow rate during the pumping. So this washer, which coming from the rubber, is going to represent the bottom valve. A similar one is going to be here as the top valve. This piston itself is going to have multiple holes once again, so this will be used to pass the water from the lower side of the cylinder to the upper side, because as we're going to push this one down, this valve will be open, taking the water up to the upper side of the pump, and when we push it up, once again this will be closed due to the weight of the water on the top of it, and this will generate the negative pressure inside the cylinder to put the water inside. So I hope it's going to be working better. Well, it's much better to show you that in the small cylinder. So the principle is going to be very easy. Again, I'm going to explain that to you. Okay, so you can see that the piston from inside here, as we are going to pull it up, this will cause a negative pressure in this area. I can test that by hand. Actually, if I'm going to try to pull it, I feel that the thing will suck my hand. Negative pressure, pull the water, fill the cylinder lower part, and as we are going to push it down, the valve will be open, and this will push the water up to the second level. During this process, I'm going to push it down. It's going to push this one down and prevent the water from leaking through the lower end. Now, how to make these parts? All these parts has been cut directly from a PVC pipe. We have the saw here. We can cut it and to the desired length, and we can simply prepare it for the next step, which is going to be the assembly. The T-junction, this is already made, so it's going to be off-shelf item. This will be supplied by the university, and by the end of your semester, we can take all the pump and put it back so we can use it later. 2 cups, okay. One of them is going, both of them are going to drill from the middle. The lower one is going to be cut it further. It's maybe it can be 8 holes or 7 holes, or whatever the number of the holes is just to allow the water to pass through while we generate the negative pressure. Well, bolts and nuts, off-shelf item. The 2 washers can be cut from the rubber we have here, and we can do it by many ways. We can, for example, use the just sketch circle, then cut it with the scissor. The piston and the rod is going to be the main challenge you are going to have for your work. Now, what will be the challenge here? This one has been machined on the turning machine. Maybe many of you don't know what the turning machine is. Is a simple machine holding the part is going to have cylindrical shape, rotate it, and we're going to have a sharp cutting tool, start to peel the upper side of the cylindrical part to form a shape. In this process, we only lower down the size. So the diameter, for example, was 60 millimeter. We take it down to 32 millimeters. Okay. Now, the dimension here is going to be too critical. Now, when I show you that, we have some resistance here. This resistance was simply going to provide a good tolerance. That's mean the gap between the cylinder and the pipe is going to be close enough to prevent the leak of the water from the side. Some other student make it a little bit smaller. It's going to move a little bit faster because the gap is going to be larger, but we have to add a ring washer around, and the ring washer is going to make the required tolerance to keep the high pressure inside the pump during the operation. So once again, we cut that to a certain thickness, to a certain diameter, then we make the holes to allow the water to pass through each time we are going to pull and push the piston. The rod is made of aluminium. We have the raw material available for the students. You have to cut it to the length, and you have to do the thread. Now, maybe you don't know what the term of thread is now, but to simplify the thing for you, is the screw shape we're going to have on the rod. We're going to do that by using a manual process, by using a device called the dice. So the dice is going to generate the thread according to the standard we're going to have. For example, this one is going to be called the M6 because the size is going to be something like 6 millimeter. And then we are going to assemble everything together. We have the piston, we cut the washer, we made the thread to the length of 25 millimeter, and we're going to use 2 nuts and washers to hold the piston and the valve on the rod. This will be the first assembly. Now I'm going to put back everything together, the pre-assembly, the final assembly, to have the pump, and once again to try to simulate the process of the movement of the pump and the operation process one, which I explained to you earlier. Also, I'm going to make another session to show you how to make the CAD model for the whole pump, which is going to be required for you in your report. I'm going to do it by using 2 softwares. The first one is going to be the SolidWorks, and the other one is going to be the NX, which is another software we are going to use heavily at the UTS for the next 3 years. Now let's assemble the parts together. I'm going to start with the large cylinder. I'm going to put the lower valve down. So I'm going to bring the screw, put the washer in, which is going to work as a lower valve. Use the bolts and nuts to hold the washer at the bottom. This is not the perfect way, but actually this was the only pump I found based on the main design, because you can see these are the more complicated one that cannot be reassembled. Okay, now I prepare the lower valve. I'm going to put the cylinder. Now the cylinder is ready with lower valve. You cannot see the light in. That means that the water will be held due to the presence of the lower valve at the bottom. Now the next step is I'm going to put the T-junction. Now you can see that the T-junction actually is going to have this curvature. That means if I'm going to look from inside, I can see that if the water coming that way will go directly to this direction. This will be the exit, and this will be the path I would like the water to follow. I'm going to put it on the other side. We're going to push the water up, and then the water will flow out, and this will cause more resistance to your pump and lower the efficiency of your pump. Be sure to put it that way. This will be sitting at the top. Now the next step is again to put the piston. To make it much easier for you, I don't want to put the piston and try to put the whole assembly in, so I will do it that way. I will close this one first, and I'm going to insert this one second, and put this one third. Well, it doesn't work. Again, I know this will be quite complicated, so I need to use some force to push it in. I think it's quite tight, so I'll try to open that. I'll try to push it by hand. Then, okay, and I will put back the parts together. Okay, so we had the pump assembled. Well, I may take you to the wheel. It's too tight. Okay, so be careful because it's going to be that tight. We're not going to put it on testing machine because this may bend the testing machine or bend your shaft. So of course the test we are going to make before we're going to run that, this should be rotate easy. Otherwise that means the throw pump is going to be stuck adding too much power on the load on the pump, on the test rig, and this of course going to pump less water by using higher amount of power. And this will be last part. Actually this won't going to be affecting the performance of the pump, but if the pumping rate is going to be quite high, we need to put this one just to take the water directly to the tank we are going to pump the water to. So usually the size of the cylinder and the size of the input water will decide what will be the amount of the water we're going to pump. Again, we said this one is going to pump something around 2.5 liter up to 3.5 liter in the span of 2 minutes, while the stroke of the pump is going to be something about 5 stroke, or let's say 10 stroke per minute. So again, some of the students, they decide to take the challenge to the higher level, so they made a larger inlet valve, as you can see here. This one is glued, I cannot move it in. And so of course that you can see that the piston inside is also going to be larger. It's going to be offsetted because it's going to be connected to the side here. And this one you can see it's going to move much better. And of course going to pump more water because the inlet amount of the water is going to be higher. And also the tolerances are better, and that's why the piston is much easier. More advanced example, you can see that they have multiple holes. It's centered, not offset to the side. Same thing, going to go up and down. The problem with these types of the pump is going to be they're going to be too hard to deassemble. They use the screw here. Now, why I'm talking about the deassembling and the assembling? Usually when you manufacture something, you need to consider the material you are going to use, how long it's going to be last, but at the same time you need to think about how I'm going to recycle it at the end of the life of the product I'm going to make. For example, here we have plastic, we have aluminium, and we have rubber. So some of these parts can be simply recycled, some are not. Now, as an engineers, we have to think about, okay, now we have these products. The simplest, the complex. So, in between, we are going to have this one. We need to consider during the manufacturing process about the cost of the material, and the cost of the assembly. This one can be assembled in 2 minutes, and this will be a part you're going to test yourself. You're going to write this section in your report about the design for the manufacturing, design for the assembly, and also design for the de-assembly. Because once again, after 5 years, for example, I'm going to use this pump for 5 years or 1 year, I need to de-assemble it and I need to recycle the materials. And that's something we are going to talk about in your report. I'm going to explain that to you further during the semester, and maybe it's not going to be within the lecture, not going to be within the lab, but I'm going to make a special session for you about these topics. So later when you come to the lab, you will see at the corner that we had asked a student to de-assemble their pumps and classify the materials according to the recyclability. So for example, the aluminum can be recycled indefinitely. It's very easy to be recycled, the lower temperature, all the melting, and also the aluminum is a precious material. You cannot find it a lot in the nature, and that's why you need to recycle as much as you can. And by coincidence, can be recycled very easy. The plastic can be recycled a little bit harder because the plastic is made of a link of mirrors. It's a series of mirrors chemically connected, and each time you are going to melt the plastic and you're going to solidify it once again, the shape of the mirrors out, and the property of the plastic will be changed. And within the time is going to be even bad for the to be recycled, so we need to dump it. And the problem with the plastic that it's going to take millions of years to decay and go back to nature, and this is one of the problems we're going to have. So that's mean if we're going to make this pump made of whole aluminium, it's going to be better than made of plastic. But we're talking about the cost on the other side. So we're talking about some of the items which can be reused, and this is something very important. Now when you design something for the future, you need to think about, okay, now can I take this part and reuse it on another product later? The question must be yes, if I can. Now you can see that actually even very simple materials around the world can cause problems, like the silicone. We have an insufficiency of it, well, we have a shortage of it in the world nowadays, and that's why we have problem with manufacturing many of the things, and the price of the electronic items and even the cars were going up because they cannot find the proper silicone to make the chips, which is the electronic chips, of course. Okay, so everything we have to consider in our manufacturing process, including reusing of the parts. So this part, I can reuse it directly without any problem because we didn't do any machining for it. For the plastic pipes, we cannot, because actually this were made to design. Maybe this part can be used directly because it doesn't have any design, it doesn't have any processes. But this length here actually has been machined to a length, a proper length that you will decide in your design procedure. All the bolts and the nuts, I can just simply put it back in the box and I can let another student use it, because usually these items don't damage so fast. Okay, so I will stop here and I will make another video later regarding how we can make the engineering drawing for this one, and before that how to make the hand sketch for the pumps, because this will be required from you in the first session of the hand tools lab. Thank you for your listening and hope to see you soon.